All right, here's the second part of lesson 8.3, and that's common properties of logarithms. Basically, these are things that when they come up when you're trying to simplify expressions that involve logs or powers, um, things that you can keep in your toolkit to simplify these expressions quickly, rather than having to either evaluate them or perform multiple operations to simplify these expressions. All these properties are for when a is greater than 0, so that means the base of the logarithm is actually bigger than 0, and when a doesn't equal 1, so the base is not 1. The first property is that logarithms of negative numbers do not exist, and this is because negative numbers cannot be written as a power of a positive base. And we actually saw that in our most recent lesson in example C, where we had the log of negative 4 base 2. And we couldn't get a solution because it wasn't in the range of 2 to the power of x. Our second property is that if we have the log of 1 with any base, that's always equal to 0, and it's because of the power of 0. When you have a power with an exponent of 0, we always get 1. The third is when we have the log of a to the exponent x base a. If we have our bases in our exponent and our log the same, they work as opposite operations, and our answer is actually just x. And I'm going to show you why with an example. And finally, if we have a exponential with an exponent of a logarithm, and again the bases are the same, we end up with just x, or just the input to our logarithm as the answer. So here's 3 examples using those properties and kind of explaining why those properties exist. So the first one is log of 1 with a base of 6. So this is actually your second common property here that we're going to demonstrate. And if we try to evaluate this as we did in the first part of our lesson, we would set it equal to 0 and rewrite it as 6 to the exponent x equals 1. So basically we're asking ourselves to what exponent do we have to raise 6 to get 1? And the answer is, of course, 0, because 6 to the exponent 0 equals 1. So in a general sense, if we had the log of 1 base a equals 0, that's our common property. If we rewrote this as an exponent, that would be a to the exponent 0 equals 1. And that's true because any term to the exponent 0 does equal 1. Our third common property is when we have a power inside a logarithm, and the power has the same base of the logarithm, the answer just works out to y, or to x, the input to the exponential. So here I'll demonstrate it. I'm going to set this one equal to y because x is already in our left side, so I don't want to use the same variable. And if I rewrote this as a power, this would be the base of the logarithm to the exponent y, or 5 to the exponent y, equals the input to our logarithm, which is 5 to the exponent x. And here, if we equate the exponents, we get that y equals x. Well, what is y? Well, if we look, actually y is the log of 5 to the exponent x base 5. And it equals x, which is the exponent. So here we've just demonstrated the third common property. For the fourth common property, I'll try to move my... That's when we have a power with an exponent that has a logarithm with the same base of our power. So again, here, if I try to evaluate it as a logarithm, or rewrite it as a log, I'm going to set this equal to y, again, not using x because it's in the left side. And if I rewrote that as a logarithm, that would be the log base 6 of y gives us this exponent. Or the log base 6 of our answer y gives us our exponent, which is log of x base 6. And what you can see here is that the inputs to the logarithms are the same with the same base. So like when we have powers with the same base, we can equate the exponents. You can equate the inputs to a logarithm if you have the same base. So we can rewrite that as y equals x. What's y? Well, y is, again, right here, 6 to the exponent log of x base 6. So I'm going to rewrite that. Instead of y, I'm going to rewrite what I had at the beginning, and that's 6 to the exponent log of x base 6. So then again, we've just demonstrated the fourth common property. So those are a few tips and tricks that you can use when evaluating logarithms.